Are you one of those DB04r users that stay awake at night worrying about destroying your 12Q remote? Yes, because these are incredibly difficult to find, unless of course you buy another DB04r remote. eBay does not come up with any results when you search for the 12Q remotes, other than other products you have to buy them with, which is a really expensive way of buying a remote. Rather than pay a couple of quid, you then have to pay 20, 30 pounds. But do not panic, I have the answer in this video. Now you can put your remote safely into your explosion-proof box and keep it away from the fireworks, because instead you can now use my app. Yes, you can now use a £400 smartphone to control your DB04Rs, simply using the Dodgy Fire software. Start by arming your Dodgy Fire software, and you'll find it goes that beautiful salmon pink colour. If that flashed, I believe many of you will remember MySpace. But now we can pick any cue we like to fire at will. Let's pick Q1, and look, Q1 fires. You'll also find that the clock handily starts counting, so you know how long it's been since you last fired a cue. If you fire another cue, the clock resets. You'll also notice that the cues you have fired go a funny grey colour, to simulate the fact that you have fired those cues. But don't worry, the button's not disabled. You can fire that cue again if you wish. This software also allows you to use the special inbuilt function keys which are not available on your 12-key remote. Yes, you can. You can use the sequence fire, for example, that will go across all your modules and sequence fire. You can also use the magic all fire button. Yes, why make your display last 15 minutes when you can have it in 2 seconds? Simply press the all fire button. Now, of course, you may be thinking, hang on a minute, John, this can't be true because these modules aren't Bluetooth. I would have to buy a Firefly or a Fire Deck or maybe that new snazzy Ignite system. Don't panic. You can convert any DB04R system into a Bluetooth system simply by using my handily made Bluetooth to RF converter. Yes, you're absolutely right. This is simply an Arduino Uno board, not an actual official board, please notice. This is the cheap and cheerful compatibility board, and an RF transmitter, and a Bluetooth transceiver. Each of these can be bought very, very cheaply online. I say a couple of quid each. So yes, for under £10, you can create your RF to Bluetooth, or sorry, my mistake, Bluetooth to RF converter circuit. And I'll even show you the software later on in the video too, so you can do it yourself. And just remember, when you're next searching for DB04R, or you wish to use it coming out of your box and not sacrifice your control, don't worry, you can use the Dodgy Fire app. Now available. So let's start by looking at the Arduino code. And the reason why I chose Arduino for this simple project is because there's lots of libraries that other users have already made, which contains lots of code which you don't have to write yourself. It saves lots of time. And actually, it wouldn't be too difficult for anybody that's not a programmer to be able to copy this project and work with it. So very simply, the first thing we're going to do is we're going to include a library called RC Switch. This is, say, another user library that somebody else has written to control lots of, you know, the various devices you get for your in-home switches, so like remote control sockets, garage door remotes, etc. It's the same chipset used in them as is used in the DB04R. It's the EV something 125, is it? I can't remember what the teardown said it was. But that's quite a common chipset, so they're using that, and they've created a system, this library, that allows you to interface with those chipsets. And we're going to set that up, and we're going to create a character called RX data, and this is going to be the serial data from our Bluetooth transceiver. We'll then set the baud rate, and we'll enable our transmitter on pin 12. Of course, you can choose any pin you like. It doesn't have to be pin 12, but that's the pin 12 that my RF transmitter is on. Now, before we get too deep into this, we need to just remember a couple of things. So the remote has a security code to make it a unique identifiable object, which of course is a little chip inside it. And I know from the teardowns that my remote, the secure code on it is effectively in hex is CC09A. Now, different remotes obviously will have different security codes, The person that's made this RC switch library, interestingly, has written another part of the library where you can attach an RF receiver, and then press your button on your remote, and you'll be able to tell you what the security code is. Or if you just want to reprogram your modules from the Arduino, you could actually use any security code you like. It doesn't really make any difference, because obviously the Arduino is effectively pretending to be the remote. So that effectively is our is our last 2.5 bytes. Is it 1.5 bytes? 1.5 bytes. And then the Q number is effectively the least significant nibble. So that's the 4 bits at the beginning, because obviously binary is read from the right to left. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yeah, so you've got 2.5 bytes as your remote security code, and then the last half a byte is the Q number, which of course can go from 0, 0, 0, 0 to 1, 1, 1, 1, which would be 0 to F in hex. But of course, the modules don't use 0, they start from 1. So your first Q is 1. Then we're looking at the serial data port to see if we've got anything on the Bluetooth coming in. If we do, we'll put that character into our RX data. And then I've got a big switch statement here, which basically means that depending on the value of RX data, it will fulfill one of these cases. So if, for example, RX data equals 1, then we'll execute this code here, which is the myswitch.send, and then I've put the binary in for firing Q1. And again, you'll see the beginning of the binary is the unique identifier security code, and then the last 4 bits is the Q number, so 0, 1, and then exactly. Then when we look at Q2, for example, you can see the last 4 bits there. I've made that 2 in binary. So I've done that all the way down for 12. Well, actually, I've done it for 15, because obviously 12 is the actual usual, the remote numbers. I've moved to hex here as well on past 9, because if you put 10 into the serial port, that will count as 2 characters, and then you've got to do loops and that to figure out how many characters you've received, etc. So just to save time and energy, I've just made, after you go from 9 to go into hex, so A, B, C, D, E, F is the last Qs. So obviously Q12 is C, and then QD, I don't know what the function is for QD, or Q13 I should say effectively. I haven't figured that out. But then Q14 is all fire, Q15 is sequential fire. And that's it. That is all the Arduino program is doing. It's taking the data from the Bluetooth port and outputting it onto the RF port effectively in the format that the chipset in the DB04r can recognize. So the next question is, how do you make the app to do this? Well, there's different bits of software available. I used the MIT App Inventor software, which is an application in browser you can use to build your program and then send it to your smartphone. There are various other bits of software. Apparently Funkable is supposed to be a better version than MIT App Inventor, and that's very popular amongst app developers. It is a very, very simple piece of software to use. All I've done is I've selected from the user interface list here, and I've just dragged in what I want. So if I want a button, you just drag it in and you position it on the screen where you want. And then you think, well, how does this whole hold together? Well, it uses block systems, and if you ever had the beauty of things like Lego Mindstorms, you will recognize this basic system. This looks a bit complicated because I've done a lot of different things like changing button colors and that, but in reality, if we just look at how one button operates, so for example Q8, you can see when you click Q8, it sends 8 to the Bluetooth client, so that will send it to the Arduino, and then the Arduino will then put that onto the DB04r. It changes the background color of that switch to grey to show that you've obviously pressed it, and then it does these 3 bits here is about the little clock down, the countdown timer at the bottom of the screen. But you can see this is all just blocks you just pull in and push together, so there's no need to worry about any sort of programming language. It is just this really basic system of using blocks, and there's lots and lots of documentation on about this that MIT provide, or that you can go on YouTube. There's lots and lots of information out there, and it's really, really simple to get going very, very quickly. It only probably took me, about an hour to build this whole thing, and get it to work. So yeah, that's really how it works. It is not at all difficult. So there you have it. That is how you can design your own piece of software to run on your smartphone via Bluetooth and then use for your DB04r. Obviously, something you'll notice here is that this is just sending data straight out again. There's no error checking on this side. However, the Bluetooth module itself will do some degree of handshaking with your phone that you can't see, which can be really useful. I've tried this at distance, and I've found that if you press a button on your phone as you're not quite in Bluetooth range, it will keep trying to send that until it can confirm from the transceiver it's been sent. So you may find there's a delay on firing, but it will keep trying to fire that channel, which is quite interesting. I didn't think it would do that, but it does do that. So yeah, if you were going to make this, obviously as a professional product, you'd need to include a bit more sort of layers of safety and security so you couldn't accidentally fire things. But ultimately, the DB04r is not a very secure unit, so how far do you want to go with it on the software side? So I hope that's been interesting.